Welcome back, Math 150. Let's take a look at our last two trigonometric graphs. We're going to be looking at tangent x and cotangent x, this one, and we're going to have a very similar approach to what we did before. We're going to talk about tangent x, but we're not going to talk directly about tangent x. We're going to talk about tangent x as being sine x over cosine x. So if we think about the graphs of sine x and cosine x, we can learn a lot about the graph of tangent x. We're all familiar with the graph of sine x. The graph of sine x looks like this. The graph of tangent x, I'm sorry, the graph of cosine x, that's what I meant to say. The graph of cosine x looks more along the lines of this one. Let me just line this up here. Okay, so the graph of cosine x is going to look more like this one. So what does the graph of tangent x look like? Well, again, it's literally taking the sine graph and dividing it by the cosine graph. And that's exactly what we're going to do. We're going to try to graph the tangent by making use of that idea. So when I want to graph tangent x, the first thing I think about is what does sine x look like? What does cosine x look like? And I do the following. I say, look, tangent's going to equal 0 when this fraction up here equals 0. Well, a fraction will equal 0 if the numerator is equal to 0. So where is that numerator equal to 0? Well, sine is equal to 0 at those 3 points. And when we're talking about the typical sine, that's 2 pi, pi, and 0. So that means that the tangent will equal 0 when the sine equals 0. That's going to give us zeros at 0, pi, and 2 pi. So we know that's where the 0 is going to come from. Now, where the denominator is equal to 0, we're going to get undefineds. And in this case, those are going to be vertical asymptotes. So when the top is equal to 0, we get our zeros, which were our x-intercepts. But where the bottom is equal to 0, those are going to be undefineds or vertical asymptotes. Where's that going to happen? Well, you're going to see that happen right here. That's going to be pi over 2. And right here, that's going to be 3 pi over 2. So those are going to be spots where our tangent graph is undefined, pi over 2, 3 pi over 2. And in other words, we're going to see our vertical asymptotes come into play there. So now we just have to figure out which direction do we go in. Does it go like this, up, or does it go this way, down? And again, another way to think about that, is the result going to be positive or is the result going to be negative? Well, when you're looking over here in this first region, between 0 and pi over 2, let me redo that, it's a little too thick there. When you look in this first region over here between 0 and pi over 2, you're talking about this region right over here. The sine is positive in that region and the cosine is positive in that region. When I divide them, we're going to be positive, and that means the tangent's going to have to go in this direction. Okay, so when we go to the next region, we're looking between pi over 2 and pi. Well, in this case, the sine is positive, but the cosine is negative. So when I divide those, the tangent will be negative. That means I've got to be below the axis. It's got to be this one and not the one that's above, but below the axis. So the tangent's going to leave that point and use that asymptote. Now when we go to the next region, we're between pi and 3 pi over 2. In that region, the sine is negative and the cosine is negative. Well, a negative divided by a negative is a positive. So that means when we go to graph the tangent, we're going to be above the axis. So we're going to look like this. And the last region, we're going to be between 3 pi over 2 and 2 pi. The sine is negative, but the cosine is positive. So we're going to get a negative result when we divide them. That means my tangent graph is going to have to look like this. Okay, so that's my graph of tangent. Now, most people don't leave the graph of tangent like this. Most people extend it out because it looks like you're kind of leaving something off here and leaving something off here. Remember, the idea is I could actually just take this guy, copy it, and I'm sorry, duplicate it. Let's duplicate it. And it would go right there. That's exactly where it would go. If I did that, we'd see it going back to another asymptote, and that asymptote would be negative pi over 2. Okay, negative pi over 2. Likewise, if you wanted to, you could copy this section right here and duplicate that, and you can paste it over here. and that would give you another asymptote at the end, and that would be at 5 pi over 2. Okay, the period of tangent, ironically, is not 2 pi. The period of tangent, it takes half the time to repeat. It goes from, excuse me, negative 2 pi over 2 to pi over 2. That's a period of just pi. Pi is the period of tangent x. Okay, that is how I like to graph the tangent. Now, what happens if we change this up a little bit? So for instance, what happens if we're doing tangent, and let me just insert a new page here, add a page. And now in this case, okay, when we're doing the tangent, what happens when we want to look at the f of x equals the tangent of 5x? Well, I'm going to do this one a little quicker because I want to show you how we can take advantage of our sine and cosine again. So there is the graph. I could think of this as sine 5x over cosine 5x, and that's perfectly okay because now my period is going to come from angle equals 2 pi because I'm finding the period of sine and cosine. That's going to be x equals 2 pi over 5. So here's my 2 pi over 5. That's going to be my period. Halfway is going to be pi over 5. Half that is pi over 10. And 3 of those is 3 pi over 10. Now, what I want to do is find out where that sine is equal to 0, because where the top is equal to 0, those are going to be x-intercepts. Well, I can imagine myself graphing the sine, and that's where the graph of sine would go, right there. So that means wherever sine is 0, tangent is 0. So sine is going to be 0 at 0. It's going to be 0 at pi over 5. It's going to be 0 at 2 pi over 5. So I can go and I can put zeros in each of those spots. And I'm doing that because I'm imagining the sine wave drawing its graph right there. Wherever sine is 0, tangent is 0. So now I want to find out where the cosine is 0, because where that happens, we're going to have our vertical asymptotes. Where cosine is 0, starting here, it's going to be 0 at pi over 10, and then 3 pi over 10, because that's what the graph of the cosine is going to look like. So that means I am going to have asymptotes at pi over 10 and at 3 pi over 10. Now I'm either going to go above or below, but I know that sine and cosine are both positive in the first quadrant. Oops, so when I divide them, I will get that positive result I'm talking about. Now, at this point in time, you can actually cheat a little bit. You can say, oh, wait a minute, there's going to be that other asymptote that's going to go back to negative pi over 10, and the tangent's going to look like this. Okay, that is the basic shape of the tangent. That's the period. It's going to keep repeating. So I'm going to copy and paste that into the next region, and I'm going to copy and paste that into the next region. And that would give me an ending point. Let's see, we're coming by pi over 10, so that's 1 pi over, that's 1 pi over 10, 2 pi over 10, 3 pi over 10, 4 pi over 10. So this last one over here would be at 5 pi over 10. Okay, that would be 5 pi over 10. And that would be an asymptote as well. You can do it by thinking about the sine graphs. Okay, wherever sine is 0, tangent is 0. And that's what we're getting right there, same x-intercepts. Wherever cosine is 0, tangent has an asymptote. So right there is one place, and right there is the other. So that's kind of a quick way to graphing tangent when you've got a different angle. Some people are going to ask, well, what happens if you throw like a 10 in front of this? What happens if this is tangent of 5x times 10? How does that change? Well, because we don't have a max or a min, we're not labeling anything on the axis. So really, it's just stretching it a little bit, but it doesn't make the graph really look all that different. So you don't have to label that. Sine and cosine, secant and cosecant you do, because we've got those bumps, those maximums and minimums that change their scale. With tangent, we're going negative infinity to infinity. Multiplying it by 10 really doesn't add much to the graph. So you're all set graphing it just like this. We are going to look at one more graph. We're going to talk about the graph of cotangent, okay? But keep in mind that cotangent is really cosine x over sine x. So we're going to graph this the same idea by thinking about what cosine and sine would do. Now, this is just x, so we've got that period we like. It's going to be 2 pi, halfway is pi over 2, and then this would be 3 pi over 2. So this time where the numerator equals 0, we're going to get our zeros, which is our x-intercepts. So wherever cosine equals 0, we're going to see those x-intercepts. Well, cosine would start here because every graph of cosine looks the same, and it would trace out that pattern. And actually, let me go ahead and draw that. It'll be a little easier for you to see. I'll erase it in a second, but this is what the cosine would look like. Because of that, I am going to put some zeros right here at pi over 2 and right here at 3 pi over 2. That's where the cosine is equal to 0. That's where the numerator equals 0 for cotangent. Those are on my graph. I'm now going to erase my cosine graph. And now I'm going to say, let's think about the graph of sine. Well, sine always looks the same. Sine is going to have that graph. Well, that's where the denominator equals 0. That's going to be our undefines. In this case, that's going to be our vertical asymptotes. So we're going to have a vertical asymptote located here at 0. Make that a little thicker so we can see a little easier. At 0, in other words, the y-axis, at pi over 2, I'm sorry, at pi, and at 2 pi. Let me now get rid of the sine graph, okay? But that's where the zeros and the asymptotes come from. Now, there are two choices for cotangents. It's either going to come from above or it's going to come from below. Well, since sine and cosine are both positive in that first region, the cotangent has to be positive. It has to be above the axis. In the next region, the sine is positive, but the cosine is negative. So we've got one of each. It's going to go below the axis. This is what the cotangent graph is going to look like. It's going to end up repeating. We could do the same sine analysis for sine and cosine, but it's going to turn out to be this way. We find out that the period of cotangent, okay, again, it's not 2 pi like sine and cosine. The period is only pi. All right, it's going to take this basic shape and it's going to repeat it. So I could put a copy and paste of this guy. Let's see if I can do it. Copy and paste. That's only the top part. But I could copy and paste this guy. Let's see if I'm gonna get too much. But I'm just gonna take that entire shape. Oops, my mistake. And it would copy and paste it all the way up and down the axis, okay? You only need to draw 1 or 2 cycles of the period. If on the homework, you just follow the directions. It's going to be very clear about how many you need to draw. But this is what the cotangent is going to look like. So again, everything goes back to using sine and cosine. Hope that makes sense. If you have any questions at all, please email me, reach out, make an appointment. Be happy to discuss this with you at any time. Have a great day, everybody.